Hello, this is Ms. DB, and in this video I'm going to go over some of the highlights from Chapter 6, Section 5 in Algebra 2, and this section is on finding real roots of polynomial equations. So our objectives are to identify the multiplicity of roots, that means more than one, and use the rational root theorem and the irrational root theorem to solve polynomial equations. All right, our only vocab is multiplicity, and we'll get to that in a minute. So in the last lesson, in 6.4, you used several methods for factoring polynomials. And as with some quadratic equations, factoring a polynomial is one way to find its real roots. And in the other parts of this chapter, we'll find some other ways. The zero product theorem from lesson 5.3 in the last chapter told us that we can find the roots or solutions, that's where it crosses the x-axis, of each polynomial equation by setting each factor equal to 0 and solving for x. We did that quite a bit. And we'll be using that again in this example. So this one, we have this equation 4x to the 6th plus 4x to the 5th minus 24x4 equals 0. And we want to solve it by factoring. So the first thing is always to see if there's a greatest common factor. And in this case there is, and there's a 4 in every one of these terms, and everyone also has an x to the 4th. So if I was doing this problem myself, I would probably do this. I would figure out what the greatest common factor was, and then I would divide every term by that. When I factor out, I think, well, that really means that I have to divide everything by 4x to the 4th. So this, 4x to the 6th divided by 4x to the 4th, you'd take 6 minus 4, and you'd get 2. And 4 divided by 4 is 1. So you write the 4x to the 4th, the greatest common factor, out front, and then what's left is the first thing in the parentheses. Then we move over to our second one. The 4's cancel. X to the 5th over x to the 4th. 5 minus 4 is 1, so that's just x left. It's a plus because this is a plus. And then 24 divided by 4 is 6. X to the 4th and over x to the 4th cancels. It's just 1, so we're left with minus 6. Don't forget to write the 4x to the 4th out front. That's important. That's one of the factors. So this now can be factored because this is a trinomial. So just like on doing FOIL, you'll put your two sets of parentheses, and you'll say, okay, the factors of -6 that would equal a 1x. -6, I could write -6 and 1, but when I add those, I get -5, so that doesn't work. -3 and 2 would give me a -1 when I add them, so that's close. So the ones that I want would be switch those signs, 3 and -2. And that's what we have right here, x plus 3, x minus 2. So now I have factored that as far as I can go. So the next step is to set each one of those parts equal to 0. So this one has to be equal to 0, and that's right here. This one has to be equal to 0, and that's equations right here. And this has to be equal to 0. Because if any one of those parts was equal to 0, it would make this equation true. And then we continue solving to find x in each one. If you divide 0 by 4, you get 0. So x to the 4th equals 0, and you take the 4th root of both sides, and you're going to get 0. So the first one will give you x equals 0. The second one would give you x equals -3, -3, and the last one would give you x equals 2. So we get three answers here. 0, -3, and 2. So we've solved this now by factoring. Now the next step would be to graph this just to check your work. You don't have to do this next step, but it doesn't take long to plug that equation into your graphing calculator or into Sketchpad or that Desmos.com online calculator, and to see if these roots make sense. You want to check and see, does it cross the x-axis at 0? Does it cross it at -3? Does it cross it at 2? So I did this in Sketchpad. This is what it looks like in Sketchpad. Here's one of the roots crossing at -1, -2, yep, -3. It certainly seems like it's crossing here at 0, and then it looks like there's a real root right here at 2. So that makes sense. That's what I got. If you had done it on a graphing calculator, it would look more like this, a little bit kind of chopped up looking. But that's okay. We still can see that it's at 2, 0, and -3. All right, so this is just another example. In this one, though, it's not equal to 0. So your first thing to do is to set it equal to 0. So you'd have to subtract the 26x squared from both sides. And I'm going to just write it in descending order, so we'd have x to the fourth minus 26x squared plus 25. Your next step is to see if there's a greatest common factor. Well, the factors of the first one is just 1 and x. This one has an x squared and a 2 and a 13. This one has 5 and 5. There's no common factors here. So I can't factor anything out. So now I check and see if I can factor it as a trinomial. Now this is a little bit tricky, but even though it's x to the fourth, it's kind of like a quadratic. And this quadratic is like you had x squared squared minus 26 and then it's x. See, the x squared is like our x. So we have something squared minus 26 something plus 25. So if I look at x to the fourth as being x squared and x squared in my parentheses, and then you're looking for the factors of positive 25 that would equal a negative 26. So that's why they use negative 25 and negative 1, because if you add those together, you get negative 26. Now I have to set each of these equal to 0. So I'm going to have two equations. Oh, not yet. Sorry. Now this can be factored again, because this is something squared minus something squared. It's a difference of two squares. And so is the other one. So this one became this part. I can factor this as x minus 5, x plus 5. And over here, this one became x minus 1, x plus 1. So now I've got four different factors, and I'm going to set them each equal to 0, and then solve each of them for x. So I'm going to get 5, negative 5, 1, and negative 1 when I solve those. And again, you can graph this and check and see if that's where it crosses the x-axis on your graph. And you'll find that it does, and then you'll know that your answer makes sense. All right, sometimes a polynomial equation has a factor that appears more than once. This creates a multiple root, or multiplicity. In 3x to the fifth plus 18x to the fourth plus 27x to the third equals 0, it has two multiple roots, 0 and negative 3. So let's look at this one quick. There is a greatest common factor in this one, and it's x squared. They can all be divided by x squared, and they're all also divisible by 3. So if I divide 3x to the fifth by 3x squared, the 3's would cancel, and I'll have x to the third. And then I would have 18 divided by 3 is 6x squared. Oh, I could have taken x cubed out, so that would be x squared, 6x, and 27 divided by 3 would be 9. And then this would be 3x to the third. And then this factors into x plus 3, x plus 3. So when I set each of these equal to 0, the x plus 3 equals 0 will give me x equals negative 3. This one will give me x equals 0. And then I have the same thing again. There is 3 roots, but these two are both the same thing. That's the multiplicity part. So the multiplicity of root r is the number of times that x minus r is a factor. So we got x plus 3 equals 0 twice, so it has a multiplicity of 2. When it has a multiplicity greater than 1, the graph bends as it crosses the x-axis. For example, look here. See how it's kind of like zoom? So it was increasing, and it's still increasing, but it had this little bend to it. That tells you that there's a multiplicity in this graph. When it just touches the graph, then you know that that one is the one that has the multiplicity of 2. It says you cannot always determine the multiplicity of a root from a graph. It's easiest to determine multiplicity when the polynomial is in factored form. All right, identify the roots of each equation. State the multiplicity of each root. So we have here x cubed plus 6x squared plus 12x plus 8 equals 0. There's no common factors. And they factored it already. That one would be quite difficult to factor, though. I want to see if I can explain how to factor this. Or maybe they will already factor it for you. If I was going to factor this, I would do it with, we worked on these before. When you have 4 terms, you can factor, oh, I just forgot the phrase for this. Where you look, you group it. Maybe it's factoring by grouping. So in these two, there is a common factor. It's x squared. And that would factor as x plus 6. Yep. And then over here, there's a common factor, and it's 4. And this would factor as 3x plus 2. That's not going to work. In order to factor by grouping, these two things have to be the same, and they're not. So how did they know to factor this as x plus 2 times x plus 2 times x plus 2? I mean, it works. You can check, but it would be difficult to do that on your own. So if I was going to get a problem like this, what I would do is graph it. So let's do that. Let's graph this. Yes, I do want to keep that. So I have Sketchpad open. I'm going to go to Sketchpad. There's that one that I had already. And I'm going to add a new page. Okay, so the one that I want to graph is, and you can see how using your graphing calculator or Sketchpad or any online graphing calculator will work too, just to check and see if you can figure out what the roots are from graphing. And then sometimes then that's enough to be able to say, oh, well, I think that this is how I would graph it. Okay, so you can see here that this is the graph, and then it looks like there's only one root, and that it's at -2. But because it like bends there, we know that it's going to have a multiplicity. So let me go back to my slide here that we were on. So if x is equal to -2, that means that I could have factored this as x plus 2, and then some other stuff. So now you can use the division tools that you know. And I'm going to do long division. You could do synthetic too. I kind of like long division though. And I'm going to say how many times is x plus 2 a factor of this. So x goes into x cubed, x squared times, so x squared will go up here. And then you multiply back, and I'd have x squared times x is x cubed. X squared times 2 is 2x squared. And then remember, your next step is to subtract. So I'm going to subtract both of these. And then I have x, get my pen back, x cubed minus x cubed is 0. 6x squared minus 2x squared would be 4x squared. Whoa. And then I bring down the 12x. And I repeat, so I say x goes into 4x squared, 4x times, and 4x times x is 4x squared, and 4x times 2 is 8x, and then I subtract again. So this is 0, and 12x minus 8x is 4x, and then I bring down the plus 8, and x goes into 4x 4 times, 4x, multiply back, 4 times x is 4x plus 8. So when I subtract, I get 0, there's no remainder. So that means that x plus 2 times x squared plus 4x plus 4, those are the two factors. But x plus 2 is done, but this one can be factored again. And that factors into x plus 2 times x plus 2. Now remember, this is all equal to 0. So now I can see how I got x minus 2 1, 2, 3 times, a multiplicity of 3. So there's one root, and it has a multiplicity of 3. And the graph shows that too. I used the graph first so that I could find the first root easier. So here's another example. Look for common factors. No common factors. So in order to get a hint at what one of the factors might be, I'm going to graph it again. So I'm going to open up my Sketchpad, and I'm going to just change this one, actually, instead of redoing it. So I need x to the 4th plus 8x cubed, x cubed, and then I need plus 18x squared. 18x squared minus 27. Minus 27. Is that all equal to 0? Yeah. So this up here should match this. Double check before I hit graph. Oh, see, I have a mistake. It should be 8x squared. Oh, I got that. Plus 18x squared. Yeah, that's right. Okay. Okay, so here's this one's graph. I'm going to zoom out. To zoom out in Sketchpad, you can drag like this. See that? So that is the whole graph. Now I'm going to zoom back in so I can see where these are crossing. This is crossing at 1 because this is 2. So this is 1. And this is at -3. So my two zeros are at 1 and -3. So that means that one of my factors is x minus 1, and another factor is x plus 3. But there's more factors than that. However, I can use these to do long division, or you can use synthetic division if you prefer. And you can do that in two ways. I could multiply these together, FOIL it together, and get an x squared, and then divide by x squared. Or you could just do one of these. I'm going to just do one. I'm going to go x minus 1 into, and then I'll write this whole thing. X to the 4th plus 8x cubed plus 18x squared. There's no x term, so I have to write plus 0x minus 27. Whoa. All right, so this is going to be, I'm going to get a different color. I'm going to go stop doing that. Okay, x cubed. X goes into x to the 4th, x cubed times x is x to the 4th minus x cubed. Subtract to get 9x cubed, because 8 minus -1 is the same as 8 plus 1. Bring down 18x squared. So this is going to, x goes into 9x cubed, 9x squared times, and then multiply back. 9x squared times x is 9x cubed minus 9x squared. And then subtract. So 18 minus a -9 is the same as plus, so 27x squared minus 0x, so x goes into 27x squared, 27x, and you just keep doing this process over and over, 27x times 1, so I get 27x minus 27. And again, you're not going to get any remainder here, meaning that it factors exactly. Okay, so then I take x to the 3rd plus 9x squared plus 27x plus 27, and I'm going to divide that by my other factor of x plus 3. So I'm going to repeat this. So I get x squared plus 3x squared, and then I subtract, and I get 6x squared plus 27x. And these will get easier as you go because they'll get shorter each time, plus 6x, and multiply back, and I get 6x squared plus 18x, and subtract, and I get 9x plus 27, and that is 9. 9 times x is 9x plus 27, subtract, you get 0. So the other thing that goes up here is x squared plus 6x plus 9, which then factors into, let's see, x minus 1, x plus 3, and this is going to be x plus 3, x plus 3. So it's the 0 of -3 that has a multiplicity of 3, because it showed up 1, 2, 3 times. When this is equal to 0, you'd get -3 3 times. All right, not all polynomials are factorable, but the rational root theorem can help you find all possible rational roots of a polynomial equation. Here's the rational root theorem. It's a little lengthy. If the polynomial, p of x, has integer coefficients, so like 1, 2, 3, -1, -2, -3, then every rational root of the polynomial equation can be written in the form of p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. This helps us find our possibility ones. All right, so here's an example of a box, and it says that its length is 4 inches greater than its width, so they're going to write that as x plus 4, and the height is 1 inch less than the width, so that's x minus 1, and then x is the width. So here's the width times length times height. All right, so we have a polynomial, and it's already in factored form. And if you factor it back together, you get the polynomial form, which looks like that. Okay, if we set that equal to 0, we already know what the factors are going to be because we already figured that out. These are the factors, but this is to help you see what the factors would be if you started with polynomial form. Plus it's equal to 12, and we had to subtract 12. Okay, so here's how you're going to decide this. The theorem says this. It says that you're going to take the constant term divided by the factors of the constant term divided by the factors of the leading coefficient. So the constant term is negative 12. Negative 12. And the factors of negative 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Those are all the possible factors of negative 12. The first term in this one is just 1. The factors of 1 are 1. So we won't have to divide by 1. These will be our possible roots. Those are just the possible ones. Not all of those will be. Those are just the ones we can test. Now, you can test that like I was doing with long division. Oh, and in this case, the width has to be positive, so we only need to test the positive. So that eliminates some of them. Now, you can use synthetic substitution to test, or you can use long division. They're representing using a table. And here's how you'd use the table. The first row represents the coefficients of the polynomial. So our polynomial was 1x cubed plus 3x squared minus 4x minus 12. That was what we started with. So these numbers are the coefficients in front of each term. Now here's the ones we're going to check. Let me just read through this. The first column represents the divisors, and the last column represents the remainders. Test divisors to identify at least one root. So they're starting with 1. And they're going to go through and check with synthetic division to see. Now, synthetic division is when we learned that already. And you start by just bringing this down. And then you go 1 times 1 is 1. And then you take 3 plus 1 is 4. And then you take 1 times 4 is 4. Minus 4 plus 4 is 0. And then you take, where am I at? Oh, 1 times 0 is 0. Negative 12 plus 0 is negative 12. So this is our remainder. It's not a root unless you get 0. And then they did it with 2. So the rule is that you would take 2. First you bring down the 1. And then you take 2 times 1 is 2. Whoops. And you put the 2 here. And then you add. 3 plus 2 is 5. And then you go 2 times 5 is 10. Put that here. Negative 4 plus 10 is 6. And you go 2 times 6 is 12, and you put the 12 here, and you get negative 12 plus 12 is 0. So this right there is going to be one of our possibles. Now, once you find 1, you don't have to keep going unless you want to. Once you find 1, you could use that to write one of our, let me just write this out. So we know that this is going to be one of my factors. And let's see, what was the whole thing? X cubed plus 3x squared minus 4x minus 12. I know that x minus 2 will divide into that. So now we could use long division and find out what we get. But here's a cool thing, is that these are going to be the coefficients. So when I do this, I'm going to get for an answer 1x squared, you reduce the exponent by 1. And you can do it with long division to see that this will happen, plus 5x plus 6. And then I can factor this with trinomial, and I think it'll work because you'll get x plus 2, x plus 3. So once you find one possible one by doing the synthetic division, it's probably easier then to look at what you have left and then to see if you can factor that. So here's all of my possibilities. I can have x equals 2, x equals -2, or x equals -3. And then the question was about width, and the negative ones don't make any sense, so the only one that made any sense was 2. You can also have irrational roots, and we'll talk more about that in the continuing sections, but here's the irrational root theorem. If the polynomial p of x has rational coefficients, and a plus b times the square root of c is a root of the polynomial equation where a, b are rational and square root of c is irrational, then a minus b square root of c is also a root. So that looks crazy, but oops, there's some text stuff going on here. So here's what it really says. It says that if you know that you have a root like 1 plus square root of 2, it says you'll also know that 1 minus the square root of 2 is a root. That's really all it's saying, is that they come in pairs. They're called conjugates. If you have one that's a plus, the other one will be a minus in there. The first term stays exactly the same. The root stays exactly the same. All that changes is the sign. If you had a plus, it'll be a minus. If you had a minus, it'll be a plus. They go together. If you have one root, you have the other. Okay? And you can use that to help you find all of them. So here's an example. And you won't have to do very many of these on the worksheet, but in 1 or 2. This says identify all the real roots of this expression. So we start by looking for greatest common factors, but there is not any. So I try to figure out what possible roots I can have. And to do that, you take the possible factors of the constant, which is only 1 and 2. So I could either have plus and minus 1 and plus and minus 2. That's all there is. And you divide it by the coefficient of the first term. Divide all of these. So I could either have plus 1/2 or I could have minus 1/2. 2 divided by 2 is 1, and -2 divided by 2 would be -1. That's the only possible roots. So now you can use synthetic division to check those, or you can use long division to check them, whichever you prefer. And you try to figure out what are the possible, which ones work. I mean, something must work, right? You can also graph it to see where it's crossing. And when you look at it, none of these work. It looks like it's crossing at decimal numbers and not at 1/2. Oh, here, there's one here, 1/2. But these two did not, so 1/2 looks like my best choice. Now, it would be pretty tricky to know that this was not -1/2. But you can zoom in, hopefully, or you can plot a point there and then find the actual value of it. So my best bet is going to be to use 1/2 as a root. So I'm going to test this with synthetic division or with long division. And with synthetic division, it's probably a little easier. You bring down the 2 first, and then you take 1/2 times 2, which is 1. So you put the 1 underneath the -9, and then we add -9 plus 1 is -8. And then you take 1/2 times -8, which is -4. And then you add, and you get -4. And then you take half of -4 is -2. Hey, it works. So the factor of 1/2 does work, or the root of, which means that x minus 1/2 is a factor. And these, remember, are going to be the coefficients of the next. So I started with x cubed, so this will be 2x squared minus 8x minus 4. And then for the rest of it, just use the quadratic formula after factoring out the greatest common factor. It's not going to be factorable, so just go ahead and use the quadratic formula, and we would find that the other roots were 2 plus the square root of 6 and 2 minus the square root of 6. So we found we are able to fully factor it now. That's what it would look like. And then you can find all of the roots, and they would be those. So that's, like I said, there will only be 1 or 2 of those on the worksheet. If you have any questions, let me know, and we'll continue working on this for a little bit longer. Thank you very much, and have a great day.